Okay, today hello. Yeah, today we are going to talk about how to generate a sample data. So, if you have a classification problem or unsupervised problem, clustering problem, so you want to generate data. So, this particular function is going to generate uh, a data which is clustered around center 1, center 2, center 3. So I'm expecting it to be in 2D. You can extend it in as many dimensions as you want. So let us suppose that you have in 2D you have certain centers. So you can assume that you have minus 1 1. This is center 1. 1 comma minus 1 another center. So minus 1 comma minus 1 is lying on, let us suppose minus 1 comma minus 1 is lying over here, then 1 comma minus 1. So because x is now shifted to 1, so you come here and 1 comma minus 1 will be here, and then 0 1. So you come here and go here. So it's like a triangle, and on the edges of those triangle, that triangle, you have the centers. So now you have this kind of center 1, center 2, center 3. So we initialize these centers. So center is basically a two-dimensional array. Centers is a two-dimensional array, the first component of which keeps that center 1, the second component keeps center 2, and third component looks at the or keeps the center 3 coordinates. Sigma is a random number that we assume that we want to spread this much. The data needs to be spread it out. So how much, uh, how 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 to how much you want to spread your data around a particular center. So that sigma is coming from random numbers. So you have generated 3 random numbers, and all of them are representing some kind of the cloud size of each cloud around these centers, right? Okay. Now we multiplied this random number because this random number is between 0 to 1. So we kept it between 0.2. Okay. We kept it exactly 0.2. So if you want to keep this, you can silent this. So just by doing this, you can actually comment it, right? Okay, so we have now fixed the sigmas to be 0.2, 0.2, 0.2 for every of the data cloud around these centers. Now, look at this thing. So what it is doing, it is generating number of points, number of data points, whatever number of data points you are getting uh, from the user. So half of them you are generating, and both the coordinates you require. Basically, you require both the coordinates, so you are generating num points by 2, number of points by 2 coordinates. Then you multiply it by the variation. So this variation will actually, random is this random is a function that generates the normal distributed data points, random data points. So once you get these randomly normally distributed random points, so you multiplied it by the variation that you want. So how much you want your data should be spread out. And then we have added the center. So because this random is actually generating, so if you see the help file of random, so it basically what it does, it actually generates the random data, normally distributed random data, and it also says that the generation of this random data is about the mean 0 and the variance is 1. So the measurement of spreading out is 1. So we multiplied by multiplying sigma 1, we are actually scale the magnitude of spread. So instead of spread 1, we want now the spread to be 0.2. And then since the mean was initially origin, now we have shifted it to center 1. So we have added this part to the data cloud just to shift the whole data cloud to that area, right? So by this x1, by this statement at line 11, what we need to do, we are actually generating two-dimensional data points and then shifting them to then multiplied by sigma 1 so as to increase or decrease the variance, the spread of the data, and then shifting them to a particular center, to a particular location in the whole thing, right? So that's the way we are going to do. So these three statements are doing the same thing. About center 1, this is going to generate data points around about center 1, this is going to generate center around center 2, and this is going to generate around center 3. Now this is a plot function. What does this plot function do? So if you want to plot or two-dimensional data, so you have to pass the first coordinate here, the second coordinate here, and you need to tell in what way you want to plot this. So I said it to be a red colored dots. Similarly, you are printing here x2, the coordinates of x2 and x3. X2s are going to be represented by green dots and x3 is going to be represented by black dots, and that's how the plotting business is there. Now the data set is entirely covering the whole thing. So the first class, which is around the center 1, we have given is class label 1. The second class we are giving the label -1, and the third class we are giving the label 0. So this 0 is actually adding a column of zeros at the end of x3. So the column is appended basically. So x3's first column is coordinate 1, x3's second column is coordinate 2, and the third column is containing all the zeros, telling you the class label of that particular uh, class. Okay, so by the save command we are actually saving this data. So I'm telling that what variable needs to be saved, and here I'm telling which file you have to create. So a mat file is a MATLAB binary file in which the data is going to be saved. So let us just see how it goes and how it runs. So this is an example call to this function. Now I'm running it on to this screen and you can see how does this plot look like. So you can see these black dots are coming over here, the red dots are coming over here, and so we had like -1, then 1, -1, and then 0 and 1, right? These are the centers. So you can see that this is how it looks like. So this is the way you can generate the data, a toy data for your problem. So if you want to do some kind of an exercise or some kind of running of your algorithms, for example, KNN algorithm or SVM or least squares. You can generate the data and try to see whether this data is actually representing uh, a particular type problem, and then you want to judge your algorithm on these data sets. Thank you.